Okay, so now we're coming to the last, where we have testimonials. And in this session, we'll hear from many about how Bill influenced their life. But before I pass the podium, I would like to say a few words about how Bill influenced my life. In 1977, I got a research associate position at CERN to work on bubble chambers. But I hope to use the opportunity to move on to electronic experiments. Julius Stumer, whom I knew from Tel Aviv, introduced me to Bill with the results that I joined his experiment, R806, at ISR. Bill was my mentor, advisor, collaborator, and friend ever since. Bill had a unique ability to identify a scientific challenge, match it to an emerging technology, and come up with an elegant design for an experiment. In 1985, Bill started planning for Rick and returning to the US. He suggested that I take a sabbatical at BNL to help organize the BNL effort on Helios. I have a suspicion that Bill expected this to be a long sabbatical. I'm still here. Helios was followed by a small heavy ion experiment at the AGS and a more ambitious proposal at Rick, the experiment Oasis, which you heard about. When the proposal was rejected, Bill's full attention turned to the proposal of GEM detector at the SSC. When the SSC failed, many of us were demoralized, but Bill was already planning for Atlas. He led the US Atlas effort when the experiment was already designed, but as you heard, he made very significant improvement to the design, even though they were resisted at the beginning by our European friends. Following Atlas, we worked together on developing the neutrino program. I think there are a few people in this audience who actually know Bill longer, but I think I hold the record as far as the number of experiments we worked together. Bill had the most fun developing the design of a new experiment and finding how to utilize state-of-the-art technology to address the science. In these efforts, he worked closely with a small team here at Brookhaven, which we developed special relationship over the year. Bill expected people to arrive at the right conclusion on their own. You heard it many, many times. At times, he could be quite opaque. Often after his visit to BNL, we would meet and try to interpret what Bill really meant. Over the years, we got quite good at it and were getting inquiries for help in interpreting Bill's messages, coded messages. At this time of uncertainty in the field, we need Bill's wisdom and insight. Personally, I miss the long discussion with Bill and his advice. I still, when my phone rings at 7:45 in the morning, I somehow think, must be Bill. It has been a privilege, a challenge, and joy and fun working with Bill. I think we all will miss him. Thank you. I now would like to ask people to come up in this order so that we can try to finish more or less on time. The next one is Thorsten Ackerson. And if people can just come up and then take on the mic and follow. You can just hold it.
Thank you. So it's been really an experience for me to hear first these different talks about Bill and to learn everything that I didn't know about Bill's activities. There were so many things that I actually didn't know that he was actually doing, and it is really very impressive. So I met Bill already as a graduate student in the very end of the 70s. Now, as a graduate student, I was absorbed by my own work, and I did not really know who he was. But I didn't have to, because his intellectual presence was immediately evident. His input was always thoughtful and impacted whatever discussion. Quite often, his thoughts came as one or two strikingly formulated sentences to reflect on, and not seldom did their effect come after a significant latency. He rarely gave very long introductory arguments. When the advisory body for this meeting had its first telephone conference, Velko said something that completely agreed with my experience of Bill, but which I had not before formulated in thoughts. Bill often proposed things, came with ideas, and then he sort of stood back quietly and enjoyed to see them happening without thoughts on his personal credit. And he had many ideas covering a broad range: accelerators, instrumentation, and the experimental exploration of particle physics. And in particle physics, his inputs were covering the whole field. He did not specialize in a narrow niche. He remained the Renaissance scientist. It was the ISR period that I remember most from the interaction with Bill. The R87, the actual field spectrometer experiment, performed excellently because of its clean design. Both the calorimeter and the central drift chamber were state-of-the-art, and the magnet was chosen to avoid all deterioration of the calorimeter measurements. Excellent results came out of the R87. Some crucial results could have come earlier, but unfortunately the late delivery of the uranium plates delayed the jet discovery with at least a year. This was, of course, completely beyond the influence from particle physicists, because the uranium was needed elsewhere for other purposes. During the ISR, and somewhat also during the following NA34 period, the Restaurant 2 at CERN played an important role. The lunches were long and creative, especially the coffee in the end. And the importance of the discussions that took place here cannot be overstated. These were also one of the occasions where Bill's cultural depth showed up. Bill was a very cultural person. And now and then, Lindsay and Bill invited the collaboration to their home in Carouge. It was always a great pleasure to come to these social events, and they were so important for the working climate, something that Bill understood the importance of. So Bill is unfortunately no longer with us, but he remains one of the best role models for a scientist. Thank you.
Okay, yeah, thank you. I forget who it was who said of theoretical physicists that there are geniuses and there are wizards, and Feynman was a wizard. Well, we all know that Bill was a wizard in the field of experimental and detector physics. We've heard so much today, and like others, I didn't know a quarter of what he was doing. I would just mention a couple of things in which he changed the direction of my life, or influenced that change in a very important way. And one was at the beginning of the ISR, CERN decided they should have a facility, a large area facility, and the split field magnet was decided upon because everybody knew that all the interesting particles went forward, and that's where you needed the magnetic fields. But then high PT physics was discovered at the ISR, and it became clear to many of us that you really needed a large area detector at the ISR to cover high PT physics in the central region. Well, an experiment that we proposed to do was turned down. This was not with Bill, but they said, well, you can do this at the split field magnet. And of course, we were very disappointed, but we did what we could there and kept pursuing this idea. And eventually, we had a proposal for a large area experiment that came back, and the committee turned it down. But Jenschke, who was the Director General at the time, he wasn't on the committee and was rather annoyed or upset that he wasn't giving a recommendation to do this. So he set up a working party to look at the possibility of a large area detector. And in fact, Zikiki was chair of this, and finally it was a stalemate because Zikiki and others wanted a toroid and we wanted a solenoid, and the committee then said too little too late, or too much too late rather, and we went home very despondent. And I was at Rutherford Lab, and I remember Bill called up, and he'd been with Chris Fabian, said to Falk Varian, and had this plan to do it as an experiment. And Bill called it, said, Mike, we can do this as an experiment and not a facility. And that way, he saw a way we could get it done. And the only reason it took us 3 months to join in with the proposal was because at Rutherford Lab, Norman and I were not supposed to do experiments without university collaborators of the UK, but finally we got that through. So that was the beginning of the AFS as far as I was concerned, and was, of course, the great experiment for the ISR. The other thing was sometime later, when I was in a difficult family situation. I'd gone to Stockholm, to the university there, and my wife and kids were back in Geneva at that time, and it was not a good period for me. And I think that I had the possibility of going to Fermilab, but that was a big decision to make, right? Personal decision. And Bill must have heard about my difficulty, and he called me up from Columbia, where he'd just gone, without me asking him to call, but he spent 45 minutes on the phone with me, which in those days was a big deal, transatlantic 45-minute call. And he didn't tell me what to do, but it was clear to me at the end of that talk what I should do, and came to Fermilab. So that changed my life and my family's life. So I owe him a tremendous debt, and of course he was a wonderful person to work with. Thank you.
So I first met Bill in the early 70s when we were both working at CERN at the ISR. Now, unlike most of the other speakers today, we were actually working on competing experiments, not together. So I thought you might be interested to hear about how his ideas on detectors and the physics results that they produced actually produced better results than the competition. I was a CERN staff member, a young one, and he came in as a senior staff position at CERN, and this in itself already showed you the high esteem he was regarded in. In those days, and still, I think, CERN doesn't usually appoint non-Europeans to these positions. I think at the time, Jack Steinberger was the only other non-European, so there you are. I was working at intersection I1 in an experiment called CCOR, and he was next, not so far away, in I8 in the experiment. I think at the time it was R806. We were both involved in high PT phenomena, and as was mentioned by previous speakers, direct photon was a very hot topic. So in CCOR, we had a very good energy resolution calorimeter, lead glass, but it had very poor spatial resolution. So to distinguish one photon from two, we used a rather crude method, which was the conversion probability in the coil of our solenoid, and we got a result. And in I8, of course, you heard from Bob Palmer and from Chris Fabian, with the beautiful detector, they were able to separate one from two photons, and they had a much more convincing result on direct photon. And that was, of course, one of Bill's achievements on there. The second example was, at some point, again, it was mentioned that CERN was building a superconducting low beta section that was supposed to go into only one of the intersection region at the ISR. And in our experiment, we requested to have it, and the AFS also did so. Actually, I found out today that they did so only to sneak in the scintillator rather than the liquid argon, but I didn't know that at the time. Okay. Too late. Anyhow, the committee, very wisely, as it turns out, chose to put it in the AFS experiment, which again turned out to be a good choice. And again, it was because of the superior quality of the detector that was in great part Bill's design. A few years ago, I retired from CERN. I came to Columbia, and so far I'd only met Bill professionally, and I was deeply touched when I arrived at Columbia. He came into my office and welcomed me in the most warm possible way. It was very good, very pleasant. I worked with Bill for the last few years. Mostly introduced me to proton decay, as was mentioned by Bonnie. We worked on that together. It was a great experience, and I'd like, also to thank Lindsay for welcoming my wife Annette and I into the region. It was a great help. So thank you.
Okay. So I am yet another one of those many people whose careers and lives took a different direction after an encounter with Bill. In my case, it was in the mid-'70s, that seminal time that we've heard so much about today. This was a time when Bill and I had been colleagues at Yale. He was at CERN at the time. This was a time when QCD was very much a work in progress. The Isabel project was very much a work in progress. And as we've heard, at that time there was this Bear Mountain meeting, and these revolutionary ideas of TD and others came out regarding the strong interaction in a way that embraced both high energy physics and nuclear physics. And I quickly learned that Bill seized on these ideas immediately and began developing an experimental program to utilize very high energy collisions of very heavy nuclei to excite the vacuum and create this new form of matter, which was being called quark-gluon plasma. This was a very compelling story, which I only understood after a few conversations with Bill. But about that time, I think it was 1978, Bill came back to Brookhaven, agreed to lead the experimental program for Isabel. And to my complete surprise, he asked me to come and help him. So it was Bill who brought me to Brookhaven. He was in that position for only a short time, but during that time, while he was at Brookhaven, working with Nick Samios and TD, and with Mark Barton, who was the head of the accelerator team for Isabel. Mark is here today. Bill saw to it that the Isabel project and CBA that followed included the capability for accelerating nuclear beams. And it was this that made it possible for us to quickly make the transition from an Isabel project to a credible relativistic heavy ion collider project very quickly after the Isabel project was canceled. And so that, for me and many others, was the beginning of what has been a scientific journey of a lifetime with Rick. We've heard already that working with Bill was not just about physics. It was also about families. And some of my fondest memories are from a year at CERN when my family and I spent many a pleasant afternoon with Bill and his family, sometimes in the house in Carouge, sometimes roaming through the Swiss countryside. And when we came to Brookhaven, we came to Long Island, Bill and his family were there to meet us. And they, in fact, put at our disposal Bill's sailboat. And this led to many more pleasant interactions with the Willis family and with quite a number of adventures with that sailboat, which I probably shouldn't describe here at the moment. But you know, it is a great pleasure to reminisce about this today and to touch base again with Lindsay and with the family. It is hard knowing that Bill is not here with us, but the fact that he was there meant a very great deal to me and to Connie and to our daughter Margot. Thank you.
So I'm another of Bill's mentees. As was said earlier, it took me a while to realize that he was mentoring me, but he was extraordinarily good at it, and he's also one of my closest friends in physics, I would say, along with his family. Now, I came up through nuclear physics, so when I first started to work with Bill in 1985, I remember this was about a year after my PhD, and I remember my mentor who got me through the PhD said, "Wow, you're working with Bill Willis? What's he like?" So I thought about it for a while, and I said, he's like everybody else, only smarter. And I think that was really true. I think I would modify that slightly in thinking about it, and after having gotten to know him better, that I think he also likes people more than most of us. And I think that was a real key aspect of why Bill has so many people that he influenced so much, and why he was such a good manager, which he was. And I certainly wish that I had written down the many, many things he told me about how he was making things happen through the ILC, how Microboon was getting approved, and all of those wonderful things in between, because, of course, I only remember some small fraction of them. I'm trying very hard to not conclude from that he thought I was best suited to management, but because that's not true. Now, many people have talked about the interpretation of what Bill meant. So this was something that always struck me also. Bill would tell me things, as he did with everyone else, and I would try to go off and listen carefully and think about it very hard. But a good fraction of the time, I would conclude that I was mystified. And sometimes I would just conclude, no matter how hard I thought about it, I was just not smart enough to figure it out. So I would go back and ask him, "What did you mean?" And Bill would sigh and smile and tell me. But I thought about this a lot as to why Bill would tell us things in a way that was, not always the most direct. And I think he actually felt that it was more fun to do things like that. Let everybody else use their creativity. He didn't want to presume that he knew the right answer, even though he generally did. And so I realized I'd like to tell you all a little story that I think illustrates the aspect of Bill's personality that made him like to tell us things in a way that was indirect or, maybe a little more challenge for the listener. I remember the first 3 times that I went to visit in Dobbs Ferry after Bill and Lindsay moved there. Bill gave me directions. It was, of course, before MapQuest and GPS and so on. And I noticed that each time the directions were different. Totally different way to get there, same house. And so the third time I asked Bill, I said, "Well, I've noticed that you always give me directions via a different route. And why do you do that?" And he said, "Well, it's boring to always do things the same way." So I think Bill's, sense of fun and interest and creativity really had a lot to do with how he told us what he thought. And certainly, though I didn't write down everything, there are a gazillion things he told me that I'm really going to work hard on remembering. And I feel really, really honored and thrilled to have been part of his physics family.
This is another story of gentle mentorship, combined with a novel detector design. So this plays at NA44 in the first half of the 90s. NA44, as Chris showed, was a very narrow spectrometer designed specifically for 2 particle correlations. And after a few runs, we realized that what we really want is to do 2 kaon correlations. Problem is, there are lots of pions around, and how can you trigger on 2 kaons in the presence of lots of pions. So Bill came up with this very, very clever Cherenkov arrangement whereby without doing high resolution or high granularity readout, trigger on 2 kaons. Very clever arrangement whereby the readout is not placed in the focal plane of the radiator, but further back in the image plane. So I had played with aerogel and Na34 before that. Bill knew that, so he encouraged me to pick up this project and run with it. So problem, of course, is at the time in the 90s, nobody had ever used aerogel for imaging Cherenkov detectors. They were just crude, I shouldn't say crude, threshold counters. So nonetheless, we set out and built a little shoebox-size detector and demonstrated that you could use aerogel to make beautiful, clean, crisp rings using aerogel if you pay attention to the right parameters. So we published that, and then a couple of seasons later, we built a full-size device for use in Na44. However, time was running out. Na44 was over, and in 1996 we packed up, and the Los Alamos team went back to Los Alamos. However, at the end, I gave some of the leftover equipment to Tom Ypsilantis, who had picked up on the idea, and then incorporated an imaging aerogel Cherenkov counter in LECB. So this is another story where, from a very, very clever idea of Bill's via novel use of aerogel, a big successful detector is now in operation that otherwise would probably not have been there. On a personal note, when we lived at CERN, my daughter was born there. At the time, the boys, David and Andrew, they were knee-high, and we spent many very pleasant hours at the home with all the little ones. And all in all, it was, in the background, of course, Bill was always pushing gently, but staying in the background. And it was probably some of the best, some of the most fun you can have as an experimentalist. And so all in all, it was a sweet time for which I'm very thankful.
I didn't know Bill Willis personally, but I'm very happy to have the chance to recount a story of how he affected my research. I was a postdoc at Yale from 1979 to 1981, and for the most part I was playing around with field theory at finite temperature, instantons, perturbation theory, and I was really just playing around. It was something to do. People hadn't done it, and it was fun. And in the spring of 1981, Bill came and gave a colloquium at Yale. I think it was April or May. It was certainly around the time that Bill Seitz mentioned of studies that were going on. And he first spoke about a heavy ion collider and using it to measure the properties of QCD at finite temperature. And I have to say, it was undoubtedly one of the most exciting and stimulating talks that I have ever attended in my life. I came out of it, I thought I was just playing games, and he showed me that this was something that could be experimentally measurable. It was just fantastic. This affected my research very deeply. I spent the summer thinking about how the rho meson would move, and I wrote a paper, and I acknowledged his colloquium in the acknowledgments. And I remember he wrote me and stated that he thought it was one of the most gracious acknowledgments that he had ever read in physics. And I went back and I looked at it, and in fact, all I wrote was, I happily acknowledge that a colloquium at Yale University by Dr. W.J. Willis stimulated my interest in this problem. Which I don't think really was that gracious. But I was very touched that he contacted me, and I'm happy to have this opportunity to say that for myself, as for many of us in this room, that he's clearly one of the people who originated this field that turned into such a spectacular success at REC and the LHC. Thank you.
So I came to Brookhaven in November '79, and a week later, my then boss sent me to CERN to participate in a test beam with the of a TRT detector. That was when the Russians, Boris Dolgoshin, Leftina, and the crew was there as well. But I didn't really interact with Bill until about '84 when I joined the Helios experiment. So move forward a little bit in '89, when Bill was getting ready to return to the U.S. and work at the SSC. And we both attended a workshop, LHC workshop about muon detectors. We heard the talk by Walter Bloom, who described all possible techniques to detect the trigger of muons. No conclusions there. As soon as we got into the car to go back, this meeting was just outside CERN, not very far, but essentially about a kilometer from our offices. Did that so that people don't get distracted by the daily work. So in the car, Bill tells me, well, if we want a detector that can do both trigger and measure muons, it has to be proportional chambers with a cathode streak readout. And of course, he reminded me of the 814 pad chambers, which is one variety of those, and the first ones that were done this way. Now, as I said, this was just a kilometer outside CERN, but for some reason that day, which I cannot remember, the family dog, Brucey dog, I guess, he was in a kennel, and Bill needed to go get him. So that was at the other side of Geneva. So that took us about an hour and a half to get back to CERN. And in view of what Nick was saying this morning, I think being confined in the car saved me from a short interaction with Bill. Anyway, during this hour and a half, we discussed, or rather, he was talking, I was listening, and didn't I know at the time that for the next 25 years of my life, I will be working on similar detectors. And 2 years later, in '91, we, along with Valery Cherniatin and Sasha Panyashin there, we proposed the cathode streak chamber detectors for the SSC. Of course, this never happened, but such detectors eventually were used in Phoenix, in Atlas, and in much larger numbers at CMS. And speaking of the SSC, and Nick's reading Jack Sandweiss's message reminded me of the following story. In '91, after the Texas site was selected, there was this big jamboree that about 1,000 people were there to inaugurate the, I guess, the Super Collider. And I found myself talking to Jack Sandweiss at the reception. And he knew that Bill and I were participating in the RD6 program, which eventually became the TRT detector in Atlas. And he asked me a question. I don't even remember what the question was, but I remember that I either did not know the answer or I wasn't sure about the answer. So I told him, you better check with Bill. Jack's face broke into a broad smile. He says, well, I guess some things never change. And he told me the story when he was interviewing at Yale for the assistant professorship, which he got, of course. He wanted to know what the group was doing, so he was asking various questions, and pretty soon the pattern developed. Every time he asked the questions, I said, better check with Bill. And indeed, that in the 30 or so years that I had known Bill, that was the case. He always knew better than anybody else. Thank you.
Thanks. I didn't really become a collaborator of Bill's until rather late in my career and his also. I'm old enough and I was around Brookhaven long enough that I knew peripherally about the development of the lithium TRD and the liquid argon. I remember the stories about the humidity and test the burning of the lithium and dimpling it to make sheets, etc. I also watched peripherally as it developed into a very successful program at the ISR. When the SSC experiments were designed, of course, I knew of Bill's contributions to the gem detector. That was the other collaboration, so I didn't follow it closely. So it was really when Atlas started that I became a real collaborator of Bill's. And in that regard, I know very well the impact that Bill had on the liquid argon calorimetry. I know personally of his impact in terms of redesigning the forward calorimeter, which actually had a big impact on the overall design. I know that he personally played a large role to get Hampton involved and establish the technical capability at Hampton and the funding to help build the TRT. And I know he worked for many years with Boris Dolgosheim, technically developing that detector. But what really impressed me was the leadership that he brought to the project as a whole. When the SSC collapsed, there was a large number of very talented U.S. physicists who had made tremendous strides in R&D, but there was no project. And to get a project involved many negotiations with CERN, with DOE, with NSF, etc. And Bill really took the lead. It's true he had a lot of help from this gentleman, Howard Gordon, who's somebody else for whom I have tremendous admiration. But Bill really took the lead, and I was all the more impressed because in my experience, the cleverer and more creative a physicist is, the less they have the tolerance for managing a large project. But Bill demonstrated that he could master that also. And frankly, Atlas would not be at all the experiment is today without the contributions of the U.S. groups. And the U.S. groups would not have made the contributions they did without the leadership that Bill provided in organizing that project and making it happen. And for that, personally, I'm very appreciative and very thankful.
I think my first interactions with Bill were actually social, because I remember being at Bill and Lindsay's house at some wonderful parties. When I became more involved with Bill was when I was on this review committee that Howard mentioned for reviewing U.S. Atlas. And I think as Barry had said, sometimes when you're on one side of the table, you end up on the other side of the table. And at some point, I was appointed the operations program manager for U.S. Atlas to replace Bill. And as Howard said, I did that with some trepidation, in no small part because I'd have to replace Bill, and those are, of course, tremendously large shoes. And when I look down, I notice there's still some space left in the shoe to fill. Then it was clear that I needed to get input from Bill during this transition, and he was very gracious about that. And I had a meeting, and you've heard this theme recurred about meetings with Bill, and his reputation preceded him, so I knew about this, and so I thought, indeed, like Bonnie said, I should listen very carefully while Bill was talking about offering advice and wisdom about the fact that he knows about the U.S. Atlas collaboration, and he was very plugged in, of course, to the agencies and so forth. So I thought this would be very important. So I listened very carefully, and as I was listening, I said, this is not so bad. I think I understand everything, and this all sounds very good. And so after that, then I went back to my office, and I said, good, I'll now try and put my thoughts together and see how to use this. And then I realized I hadn't really understood anything. But then over the course of a couple of weeks, what I realized was I started to understand more. And what I realized was that Bill had been thinking about 12 chess moves ahead. And, I'd been left back at the first chess move, and perhaps I'm still only like at the sixth chess move at the moment. So it was very helpful, and indeed I will also miss his wisdom and his insight. and I think we owe him a great debt, particularly in Atlas. Thank you.
Hi. So Bill came to Columbia in 1990, as we heard, actually about a month after I arrived there myself as a young postdoc fresh out of graduate school. And of course, I didn't know at the time what a profound effect he would have on my life since then. And it's really in a variety of areas. So we heard before about sort of the intellectual debt which we hold. In fact, one of the very first things, ironically, that I did at Columbia was we were trying to understand why the Zeus calorimeter, which we were working on at the time, building and doing test beam at Fermi, why it was compensating. We heard a little bit from Velko how Bill had come with this idea, but in fact the explanation wasn't quite right. But even in being not exactly right, he found a very important concept. So Alan Caldwell and I did used some custom electronics to do some measurements at Fermilab and really try to gain some insight into what was going on in that. And the intellectual debt continues and still continues, and so I can bookend almost the very first thing I did at Columbia with the last thing which I did this week. So 2 days ago I submitted finally, after grueling internal reviews as Atlas works, an Atlas paper on non-pointing photon search in supersymmetry, which unfortunately we didn't find. That's not Bill's fault. But this is an analysis. I'll spare you all the details, but it would be impossible. It's really unique ability of Atlas to measure the direction of photons, as Howard mentioned. And it's something which the two experiments are quite complementary. When people say, well, what can your experiment do that the other experiment can't do? Well, that's one thing that our experiment can do that the other one can't, and it's really because of Bill. And so the very last thing which I did before coming here basically is an analysis which was really an enormously fun to work on and would really have not been possible without Bill's many contributions to the experiment. In terms of, I'd like to also mention, people have talked about his generosity in trying to help other people, not worrying so much about his own credit, and that was really also very true and has been very important in my career. So when Bill arrived at Columbia, Nevis already had a long tradition of excellence in developing electronics, but we were really sort of at a threshold where we had to make a transformation from the sort of technologies that were used before to the highly integrated technologies that we use today. And we were not equipped to do that. And so when Bill came, he was trying to think, okay, what could he do to sort of help others, help the institution be a better place? And so he was nominated for and subsequently awarded a Keck Foundation award. And so he got all this money, and his question was, what would we do with this money? And what he decided was what Nevis really needed, and he was spot on, was to build a state-of-the-art infrastructure, a laboratory where we could do that sort of electronics development. And Bill was doing many other things, as we've heard. So in fact, over the next several years, I had the enormous pleasure of spending all of Bill's money. And we built this laboratory, and without the infrastructure, without that equipment, we would not have been able to do the subsequent developments in Atlas and the things which you've heard about in other experiments that Nevis has contributed to even today. So this was something where, again, Bill just wanted to see good things happen. He didn't care about the spotlight. He just wanted to facilitate in any way that he could, and it was really very dramatic. His generosity also extended on the more personal. So we had in the early days of Atlas, as Howard mentioned, the U.S. was very welcome, but we shouldn't change anything. And so there were some contentious discussions that we had with the European collaborators as we were trying to get certain ideas accepted and also take on certain responsibilities in the U.S. And in the early days, I hosted at Nevis the first electronics workshop for the liquid argon calorimeter, where we brought the people from the U.S., but all of our European and international collaborators to Nevis. And we had a several-day meeting to try and understand, first of all, how to design the electronics that we needed, but also how to figure out how to work together, which was very important in that time to establish those relationships. And so again, Bill was doing other things, but when it came to really trying to meld this collaboration together, he stepped in again, and he offered, hopefully having already discussed it with Lindsay, to host the dinner at his house. So we all trooped over to Bill's house, about 50 of us or so. And I remember Bill, at the barbecue and talking with everybody. And it was really a meeting out of which, from that sort of social gathering and sort of the establishing those personal relationships, the collaboration really came together. And we built on that success to go on from there. And finally, let me just say so we've heard about Bill's intellect, which I think was really a towering intellect. I saw him in many forums, many rooms full of very bright and creative people, and his intellect really always stood out. But in addition, he had really something which is perhaps even more unusual, and certainly in combination, which is really an amazingly warm heart. And so my family, my wife and my two, at the time, very small daughters, spent a lot of great times with Bill and Lindsay and Andrew and David and Floridora, the dog, at their house. And for my two toddler daughters, it was also a spectacular place to go. The boys inherited Bill's very warm character, and the girls really loved them. And so it was really a great time, and I thank them for that. Thank you.
Okay, thank you. Okay, well, dear Lindsay, Willis clan, colleagues, friends, it's clear that today's talks and reminiscences that we've been hearing, we've all learned a lot about aspects about Bill we didn't maybe know so much about, and even some things we didn't know anything at all about. Of course, today is tinged with sadness, but I hope and I'm sure the family has enjoyed hearing how much Bill meant and in how many different ways to so many colleagues and friends. I'd like quickly, if I may, to add a couple of personal memories. You heard this morning from Chris Fabian about the Helios experiment, and he showed a diagram of it, and in the middle, one of the tiny detectors, there were many, was a thing called the MagCal, which was a calorimetrized room temperature dipole magnet, calorimetrized yoke, and I was in charge of the little RAL group. Mike had left me on my own by then and gone off to Stockholm, and I was in charge of building that at Rutherford. And you know how these things are, it's always a last-minute rush. And the last thing we did before packing it up and putting it on a lorry truck for CERN was to check the water cooling. Of course, the conductor had a hole in it to carry the water. And unfortunately, we left some water in the coil. Well, I've done stupider things and got away with it, but as luck would have it, the night that this lorry transported this thing over to CERN was the coldest night on record since records began. I think it was below minus 20 centigrade or something as it came over the Jura. And so when we unpacked opened up the case the next morning at CERN, it soon became clear that something was wrong, and the potting was cracked. And of course, what had happened was the water had frozen, and we all learn, or should learn at school, that frozen water expands. Well, let me just say I was very, very glad that the group leader I had to report this to was Bill Willis, and not some of the people who were around CERN at the time. Happily, the coil was not quite so badly damaged, and all went reasonably well. But a few weeks ago on British TV, they showed a docudrama about the 1986 Challenger disaster and the story of Feynman and the O-rings. I don't know if it's been shown here on William Hurt as Feynman, which is quite good. And remembering that, and soon after, in fact, it must have been 1987 at CERN, one of those long lunches, but very useful lunches, working lunches, that Torsten talked about at CERN, must have been 1987. Bill made a remark. He said, apropos Feynman doing the dunking of the O-rings into the iced water, he said, Bill said, It shows if you want the right answer, ask a physicist. So this program reminded me of Bill saying this and thinking about it. And my own Willis time constant, which I think is the time it takes you to absorb 1/E of what Bill told you, is about 10 years. So I'm just about, okay. Thinking about this, it occurred to me that this can be formulated as a law. Like most laws, it comes in various forms. There's the strong form, which is that all physicists always give you the right answer. Now, sadly, that is easily proved to be wrong. There's the weak form of the law, which is that some physicists sometimes give you the right answer, but hell, that's even true of politicians, so that's not very good. And then, as you probably anticipate, there is the correct version of the law, which is if you want the right answer, ask Bill. And it has been a pleasure and deeply affecting. I would remember that today. Thank you very much.
I'm pleased to have the opportunity to say a few words in testimony of Bill today. I come with two sets of words, so to speak, some official ones and some personal ones. And so first, in official capacity, on behalf of the spokespersons of the Atlas experiment, past and present, Peter Yenny, Fabiola Giannotti, and Dave Charlton, I'd like to express the deep gratitude of the Atlas collaboration and of all the Atlas managements for the strong leadership and technical contributions that Bill Willis made to Atlas. Speakers such as Velko and Chris and Howard described a lot of the technical contributions and the leadership contributions. I'd like to convey the unequivocal message that these were vital and invaluable contributions to the success past and future of Atlas. In recent discussions, Peter commented on Bill's tireless efforts during his U.S. Atlas leadership to maximize the benefit of the overall Atlas experiment with the resources available to U.S. Atlas. He was a very loyal colleague to the collaboration and certainly contributed very constructively in shaping and improving the detector. Fabiola added that Bill Willis was a very creative physicist and a man of great personal warmth who will be sorely missed. Our thoughts and condolences go to his family and friends. So now on a more personal note, and as someone who's had the pleasure of working with Bill both at the beginning of my career and in later stages, I'd like to make my personal remarks. So imagine arriving as an 18-year-old freshman at Yale and meeting your freshman advisor, and it's Bill Willis. So when I was accepted at Yale in 1968, I enrolled in a special curriculum that was called Early Concentration in Physics. That's how I encountered Bill. The early concentration was his baby. It consisted of a 1 hour, three times a week lecture given by another professor and an evening seminar given by Bill. But before I describe the flavor of the seminar, I'd like to go back to the first encounter. So I don't remember everything about that first advisement. What I do remember is that at some point we reached a comment like, "Now that I failed to talk you out of being a physicist, I want to convince you not to be a theorist." Well, of course, I have. Let me go on. This is not directed specifically at me, because the next line was something like, "There are only 3 good theorists in the world, and all the others spend all their time wishing that they were good." He didn't tell me which the 3 were, by the way. So I imagine that the real message here was that students starting their studies spend all their time looking at textbooks, and that looks like theory, and that somehow they get the image that the theory is the top of the totem pole. And he was trying to get away from that view. For me, his advice was correct. Exploration by experimentation is the thing for me, and Bill was undoubtedly influential in my reaching that direction. But going back to the early concentration, what did Bill discuss in the evening seminar? We spent the entire year on just 2 topics, angular momentum and special relativity. A bit unusual. Does that surprise you? Each topic was approached in a typical Willis fashion. Consider angular momentum. In a semester and a half, we covered both classical and quantum angular momentum. But here again, let me tell you a little anecdote. Try to, again, imagine a freshman, sort of maybe immediately after parents' weekend in the fall, never having encountered an exam yet, go into the first midterm examination, and it's his. The problem had one problem, only one problem, and the problem was something like this. Jackie Onassis, that name kind of sets the era for us, doesn't it? Now think of her persona. Jackie Onassis is bored with the seasons occurring with the same regularity year after year. So she decides to shift the North Pole, the axis of rotation, by 10 feet. The pattern of the seasons is then richer and repeats only every 7 years. This will help enrich her wardrobe or need for wardrobe. How long can she afford to keep the Earth in this configuration? Now, nothing more was provided than this. No numbers, not even how much money Aristotle had. He'd answer certain questions on demand. So, as usual, of course, Bill had the solution to the problem as well. And he had a scheme to save her money. He only presented this after the exam, of course. He suggested that she dam the Straits of Gibraltar. Now, you see, the water, more water evaporates from the Mediterranean than flows in through all its tributaries. So dam the straits, change the inertial tensor of the Earth, and the axis of rotation will move by itself. Okay, so I could go on about angular momentum. Of course, I studied it for a semester and a half. But let me move on to special relativity. Here he started by explaining space-time, but he very quickly explained that a universe with just 2 spatial dimensions and with 2 time dimensions would be much more interesting than our universe of 3 plus 1. So that's the way we studied special relativity. So I had the pleasure, or shall I say the stimulation, to have Bill as my undergraduate advisor for 4 years, and then to have him for my graduate advisor for another 4 years. So let me tell you about my first task as a PhD student. Shortly after arriving at CERN, he asked me to build what I think was the first lead liquid argon electromagnetic calorimeter. Of course, that's what I thought I was doing. I thought I was building it by myself, but I was equipped with a cryogenics technician, Velko's wisdom, but also the able guidance of the Yale postdoc, who was Pavel Rehak, who many of you know. In any case, this was really, can you imagine a graduate student today getting an experience like that? I wish I had time for more anecdotes. For instance, I could tell you what his advice was on how to approach upper division courses, how to TA, how to get your thesis typed, how to find a job, and so on and so on. But let me just move on to much shorter account of some more recent times. I've had the stimulation of joining Bill on the right after the demise of the SSC, when representatives from the SSC program went to CERN to meet with the directors. And after that, to work with him again for another roughly decade and a half on the Atlas experiment before he moved on to other things, leaving me behind. Some of the things that he's done since then, I've had the privilege of observing from the point of view of an external reviewer, such as the heavy ion initiatives and liquid argon for neutrinos. So just to complete, Bill Willis obviously had a very big influence on me and my career, just as he has had upon our entire field. Thank you.
Before we go to the reception, there's a few words which Tom Willis would like to say.
I'll be brief. I just wanted to, I was delegated for Lindsay, who wanted to say some words, but wasn't convinced she could get through it without crying, so I'm not sure I'll pull that off either. But Anyway, it's been amazing for us to watch all of you describe Bill's career. And having been born in 1967, this is my life sort of flashed before my eyes here. And I think a theme that I hear from these talks, and which really resonates with me, is the lack of distinction that my dad made between his professional life and his family life. They were interchangeable. I was in there rolling, dimpling transition radiation lithium foils and lifting heavy uranium plates. And all of you were in our home at collaborations dinners and at Thanksgiving dinners. And, it was very much of an extended family feeling, his professional colleagues. So, I've tried to learn a lot from my dad's career, as illustrious as it was. And for a while, I took it a little too far and tried to become a physicist, which I don't recommend if you have a father like Bill. But what I did realize is that extracting from his life is that it's really important to have some skills. That's a good thing. But as important is to find people who have skills you don't have, and to learn how to collaborate with people and to get them to work on your problems using whatever techniques you can. Something I've been trying to do for the rest of my life, and I know he feels very strongly that that's that he could not have achieved what he could have achieved without having the collaborators that he had. For all these, you're correct. Talk of his disdain for credit seeking. You shouldn't confuse that with his indifference to acknowledgement and appreciation. I think were he in this room today, would be extraordinarily his inherent modesty would be deflecting credit everywhere which way he could. But deep down, I think he would be as pleased about anything in his life that his ideas are as well respected by you as you have explained today. And so thank you on behalf of the Willis family. Thank you for letting us relive his career, and looking forward to the dinner.
Okay, it's been a great day. We couldn't make it any better, so we're going to go outside and have a little reception.